Think about this. By 2025, humans will once again walk on the moon, but this time, it won't be the bulky, restrictive suits of the Apollo era. Today's space explorers will step onto the lunar surface wearing advanced space suits designed to tackle some of the harshest environments imaginable. From scorching heat to freezing cold, deadly radiation to the vacuum of space, these suits are more than just protective gear, they're life-sustaining marvels of engineering. But what exactly makes them so revolutionary? How do they shield astronauts from the moon's extreme conditions, and what do they tell us about the future of living and working on alien worlds? In this video, we'll dive into the cutting-edge technology behind these suits, explore how they're built to handle the unforgiving challenges of space, and uncover how they're paving the way for humanity's next giant leap. Ready to see how science fiction is becoming science fact? Let's get started. Space suits have come a long way since their humble beginnings during the early days of human space exploration. The first suits, like those worn during the Mercury missions in the 1960s, were essentially modified high-altitude flight suits. They were designed to keep astronauts alive in the vacuum of space, but they offered little in terms of mobility or flexibility. Imagine trying to perform complex tasks while wearing what felt like a pressurized balloon. It was a far cry from the sleek, high-tech gear we associate with space travel today. Then came the Apollo era, where spacesuits took a giant leap forward. These suits were designed not just for survival, but for exploration. Astronauts needed to walk on the moon, collect samples, and set up experiments, all while enduring extreme temperatures and the unforgiving lunar environment. The Apollo suits introduced features like multi-layered insulation, reinforced joints for better movement, and life support systems that allowed astronauts to work outside their spacecraft for hours. They were a marvel of engineering at the time, but even these suits had their limits. Lunar dust, for example, proved to be a persistent problem, clogging mechanisms and wearing down materials faster than expected. Fast forward to the present day, and we have the Extravehicular Mobility Unit, or EMU, used on the International Space Station. These suits are more advanced than ever, with improved mobility, better temperature regulation, and enhanced life support systems. They're designed for the microgravity environment of spacewalks, where astronauts repair equipment, conduct experiments, and maintain the station. But here's the catch: while the EMU is perfectly suited for low Earth orbit, it's not built for the challenges of alien worlds. Consider Mars, for instance. The red planet's thin atmosphere, extreme temperature swings, and pervasive dust storms would overwhelm current suit technology. And then there's Europa, Jupiter's icy moon, where radiation levels are off the charts and the surface is a frozen, alien landscape. These environments demand more than just incremental upgrades. They require a complete reimagining of what a spacesuit can do. This brings us to the next frontier, designing suits specifically for extraterrestrial exploration. We're no longer just thinking about surviving in space, we're thinking about thriving on other worlds. What would it take to create a suit that's not just durable but adaptable? One that can handle the unique challenges of Mars, Europa, or even more distant destinations. The answers to these questions will shape the future of space exploration, and they're already driving innovation in ways that could redefine what it means to explore the cosmos. Imagine stepping onto the surface of Mars, where the thin atmosphere offers no protection from the relentless bombardment of solar radiation. Or picture yourself on Europa, Jupiter's icy moon, where temperatures plummet to hundreds of degrees below zero and the surface is shrouded in perpetual darkness. These alien environments are nothing like Earth or even the Moon, and they present challenges so extreme that even the most advanced technology must adapt to survive. One of the most pressing hazards is radiation. On Earth, our atmosphere and magnetic field shield us from harmful cosmic rays and solar particles. But on Mars, which has only a fraction of Earth's atmospheric density, astronauts will be exposed to radiation levels hundreds of times higher than what we experience here. This isn't just a short-term risk. Prolonged exposure could lead to severe health issues, from cancer to damage to the central nervous system. Advanced spacesuits must incorporate materials that act as a personal shield, blocking or deflecting these dangerous particles without adding excessive weight or restricting movement. Then there's the issue of temperature extremes. On Europa, the surface is a frozen wasteland, with temperatures dropping as low as -260 degrees Fahrenheit. But on the other side of the spectrum, Venus boasts surface temperatures hot enough to melt lead, hovering around 900 degrees Fahrenheit. Space suits designed for these environments need to be more than just insulated. They must actively regulate temperature, using advanced cooling and heating systems to keep the wearer safe in conditions that would otherwise be instantly fatal. And let's not forget the toxic atmospheres. Mars' thin air is mostly carbon dioxide, making it impossible to breathe without life support. Meanwhile, Europa has no atmosphere at all, exposing anyone on its surface to the vacuum of space. Even more extreme are worlds like Titan, Saturn's largest moon, where the atmosphere is thick with methane and other hydrocarbons. A spacesuit for these environments must not only provide oxygen, but also filter out or resist corrosive gases that could damage its systems, or worse, harm the astronaut inside. Low gravity adds another layer of complexity. On Mars, gravity is only about 38% of Earth's, while on Europa, it's even weaker. This might sound like a benefit at first, but it poses unique challenges. Moving in low gravity requires suits that are both agile and stable, allowing astronauts to perform delicate tasks without floating away or losing their footing. And because low gravity can weaken muscles and bones over time, suits might need to incorporate resistance systems to help astronauts stay healthy during long missions. These challenges might seem insurmountable, but they're exactly why the design of advanced spacesuits is such a thrilling field of innovation. From radiation-blocking materials to self-regulating thermal systems, engineers are pushing the boundaries of what's possible to create suits that can withstand the harshest conditions imaginable. And as we'll see next, the technologies being developed to overcome these obstacles are nothing short of groundbreaking. One of the most groundbreaking advancements in modern spacesuit design is the use of self-healing materials. Imagine you're exploring the jagged surface of an alien moon and a sharp rock tears through your suit. In the past, that could spell disaster, but not anymore. Self-healing materials are designed to repair minor punctures and tears on their own, almost like how your skin heals after a small cut. These materials often rely on special polymers embedded within the fabric. When damaged, these polymers react to the stress, forming new chemical bonds to seal the breach. It's not just science fiction, it's real technology that could save lives in the harsh conditions of space or on distant planets. The implications are enormous. On missions where resupply or repair isn't an option, a spacesuit with self-healing capabilities could mean the difference between life and death. It also extends the lifespan of the suit itself, reducing the need for frequent replacements and making long-term missions more sustainable. But what happens when the environment throws more than just sharp rocks at you? That's where the next innovation comes into play. Advanced thermal regulation systems designed to keep astronauts safe in the most extreme temperatures the universe has to offer. Now let's talk about one of the most critical challenges astronauts face in alien environments: extreme temperatures. Whether it's the blistering heat of the moon's surface, where temperatures can soar to 260 degrees Fahrenheit during the day, or the bone-chilling cold of Mars, where nights can drop to -80 degrees Fahrenheit, maintaining a stable internal temperature is absolutely vital. Without advanced thermal regulation, even the most durable spacesuit would be useless, leaving astronauts vulnerable to conditions that could be fatal within minutes. This is where cutting-edge thermal regulation systems come into play. These systems are designed to tackle both extremes, using innovative technologies like phase-change materials and liquid cooling. Phase-change materials work by absorbing or releasing heat as they transition between solid and liquid states, effectively acting as a buffer against sudden temperature changes. Think of it like a high-tech sponge that soaks up heat when it's too hot and releases it when it's too cold. Meanwhile, liquid cooling systems circulate coolant through tiny channels embedded in the suit, ensuring that heat is evenly distributed and dissipated. Together, these technologies create a stable microclimate inside the suit, keeping astronauts safe and comfortable no matter what the environment throws at them. But why does this matter so much? Well, consider this. On the Moon, the temperature difference between day and night is staggering. Without proper thermal regulation, an astronaut could go from overheating to freezing in a matter of hours. On Mars, the thin atmosphere offers little protection from the planet's harsh climate, making thermal control just as crucial. These systems aren't just about comfort, they're about survival. And as we push further into the cosmos, exploring worlds with even more extreme conditions, the need for reliable thermal regulation will only grow. Of course, thermal regulation is just one piece of the puzzle. As we venture deeper into space, another invisible threat looms: radiation. But that's a story for the next chapter. Cosmic radiation and solar flares might sound like something out of a sci-fi movie, but for astronauts venturing into deep space, these invisible threats are very real and very dangerous. On long-duration missions, astronauts are exposed to high-energy particles that can damage cells, increase the risk of cancer, and even affect cognitive function. This is where one of the most critical innovations in advanced spacesuits comes into play: radiation shielding. Modern spacesuits are no longer just about keeping astronauts warm or providing oxygen. They're now equipped with cutting-edge materials designed to block harmful radiation. One of the most effective materials used is polyethylene, a lightweight yet incredibly dense plastic that's rich in hydrogen. Why hydrogen? Because it's excellent at absorbing and scattering high-energy particles, acting like a microscopic shield. Some suits even incorporate hydrogen-rich compounds layered into the fabric, creating a barrier that's both flexible and protective. But the innovation doesn't stop there. Researchers are exploring wearable shielding technologies that could be integrated directly into the suit's design. Imagine thin, flexible layers of advanced materials that not only block radiation but also adapt to the astronauts' movements, ensuring they're protected without sacrificing mobility. This is a game-changer, especially for missions to Mars or beyond, where radiation exposure is one of the biggest challenges. Speaking of mobility, that's another area where these advanced suits shine. Balancing protection with flexibility is no easy feat, but it's essential for astronauts who need to perform complex tasks in zero gravity or on alien surfaces. The same materials that shield against radiation are carefully engineered to allow a full range of motion, so astronauts can move freely while staying safe from the unseen dangers of space. It's a delicate balance, but one that's absolutely critical for the future of space exploration. Traditional spacesuits have long been a marvel of engineering, but they come with a significant drawback: limited mobility. Imagine trying to perform delicate tasks like repairing equipment or collecting samples while wearing a bulky, rigid suit that makes even simple movements feel like a workout. Traditional designs often restrict bending, grasping, and even walking, turning what should be routine tasks into exhausting challenges. This limitation isn't just an inconvenience, it's a serious barrier to exploration and productivity in alien environments. Enter the next generation of spacesuits, where enhanced mobility and flexibility take center stage. These cutting-edge designs leverage innovations like soft robotics, exoskeletons, and advanced flexible materials to revolutionize how astronauts move and work. Soft robotics, for instance, mimics the natural flexibility of human muscles, allowing suits to bend and stretch with the wearer's movements. Exoskeletons, on the other hand, provide structural support without sacrificing agility, enabling tasks that require both strength and precision. A standout example is NASA's Z2 prototype suit. This futuristic design incorporates flexible joints and advanced materials that allow astronauts to move with unprecedented dexterity. Whether it's bending down to examine a rock formation or reaching out to manipulate a tool, the Z2 suit makes these actions feel almost as natural as they would on Earth. But it's not just about movement. These suits are also built to withstand the harsh conditions of alien environments, offering protection from extreme temperatures, radiation, and even micrometeoroids. The integration of these technologies doesn't just improve mobility, it transforms how astronauts interact with their surroundings. In environments where every movement counts, the ability to move freely and confidently can mean the difference between success and failure. And as we look to the future, these advancements in mobility are paving the way for even more ambitious missions, from exploring the rugged terrain of Mars to navigating the icy moons of Jupiter. By combining flexibility with durability, these next-gen suits are redefining what's possible in space exploration and setting the stage for humanity's next giant leap. One of the most critical breakthroughs in modern space suit design lies in the integration of life support systems technology that keeps astronauts alive in environments where the air is unbreathable and resources are scarce. Imagine being on Mars, where the atmosphere is 95% carbon dioxide. Without a reliable way to breathe, even the most advanced suit would be useless. That's where innovations like MOXIE come into play. This compact device, tested on the Perseverance rover, is a game changer. It takes carbon dioxide from the Martian atmosphere and converts it into breathable oxygen. It's like having a miniature oxygen factory built right into your suit, ensuring you can breathe even when the planet around you offers no air to inhale. But oxygen generation is just one piece of the puzzle. Advanced suits also need to tackle carbon dioxide removal and water recycling. On Earth, we take these processes for granted, but in space, every molecule counts. Systems like the Environmental Control and Life Support System, or ECLS, used on the International Space Station, are being miniaturized and adapted for suits. These systems not only filter out harmful CO2, but also recycle sweat and even urine into clean drinking water. It's a closed-loop system that maximizes efficiency, ensuring astronauts can survive for days, weeks, or even months without resupply. The challenge, of course, is making these systems lightweight and reliable. Every gram added to a spacesuit increases the energy needed to move and operate it, which is why engineers are constantly pushing the boundaries of materials science. Nanotechnology, for instance, is being used to create filters that are both lighter and more effective. And then there's the issue of power. Life support systems require energy, and in the vacuum of space or the barren landscapes of alien worlds, solar panels or compact batteries need to keep everything running smoothly. These innovations aren't just about survival, they're about enabling exploration. With reliable life support, astronauts can venture further, stay longer, and focus on the mission at hand rather than worrying about their next breath or sip of water. And as we look to the future, these systems will only become more sophisticated, paving the way for longer missions to the Moon, Mars, and beyond. Speaking of staying connected, Another crucial aspect of advanced spacesuits is how they handle communication and data integration. After all, what good is a suit if it can't keep you in touch with your team or relay vital information back to Earth? Let's explore how these next-generation suits are bridging the gap between isolation and connectivity. Imagine being millions of miles from Earth, surrounded by an alien landscape, and still being able to communicate instantly with your team or access critical data with just a simple voice command. That's the power of smart communication systems integrated into advanced spacesuits. These systems are designed to keep astronauts connected, informed, and in control, no matter how far they venture into the unknown. At the heart of this innovation is the heads-up display, or HUD, which projects essential information directly onto the astronaut's visor. Think of it like having a high-tech dashboard right in front of your eyes, showing everything from oxygen levels to navigation coordinates. The Artemis suit, for example, features an augmented reality visor that overlays real-time data onto the environment, helping astronauts make quick, informed decisions without fumbling through bulky devices. It's like having a personal assistant that's always one step ahead, guiding you through the mission seamlessly. Voice-activated controls take this a step further, allowing astronauts to operate their suits hands-free. In the middle of a critical task, there's no need to stop and press buttons, just speak, and the suit responds. This not only saves time, but also reduces the risk of errors in high-pressure situations. And with real-time data transmission, every piece of information, from suit diagnostics to environmental readings, can be instantly relayed back to mission control. This constant flow of data ensures that astronauts and their teams on Earth are always on the same page, even when separated by vast distances. But what makes these systems truly groundbreaking is the role of artificial intelligence. AI acts as the brain behind the suit, analyzing data, predicting potential issues, and even offering solutions before problems arise. For instance, if an astronaut's oxygen levels start to dip, the AI might suggest adjusting the suit's settings or rerouting to a safer location. It's like having a co-pilot that's always watching your back, ensuring safety and efficiency in the most challenging environments. These smart communication systems aren't just about convenience, they're about survival. In the hostile conditions of space or alien worlds, staying connected and informed can mean the difference between success and disaster. And as we push the boundaries of exploration, these technologies will continue to evolve, making the impossible a little more possible with every mission. Now, let's talk about something that feels like it's straight out of a science fiction movie: AI-powered assistants built directly into advanced spacesuits. These aren't just suits, they're smart, self-aware systems designed to keep astronauts safe and missions running smoothly. Picture this: an artificial intelligence embedded in your suit, constantly monitoring your vital signs, checking the integrity of your equipment, and even offering real-time advice during critical moments. It's like having a personal mission control center right there with you, no matter where you are in the cosmos. One of the most exciting aspects of this technology is its ability to adapt to unexpected challenges. For example, if a suit's oxygen system starts to malfunction, the AI can diagnose the issue within seconds and guide the astronaut through the repair process. It can also monitor heart rate, body temperature, and even stress levels, ensuring that the wearer stays in peak condition. This kind of real-time feedback isn't just convenient, it could mean the difference between life and death in the unforgiving environment of space. Take IBM's Watson, for instance. Originally developed for Earth-based applications, this AI system has been adapted for space exploration, showcasing its potential to assist astronauts on long-duration missions. It's not just about crunching data, it's about providing actionable insights in a way that's intuitive and immediate. Whether it's suggesting the safest route across a rocky alien terrain or alerting the crew to a potential equipment failure, AI-powered assistants are redefining what it means to be prepared. But here's the thing, these systems aren't just smart, they're tough. In the harsh conditions of alien worlds where temperatures can swing from scorching heat to freezing cold in moments, durability is non-negotiable. The AI and the hardware it runs on must withstand radiation, extreme pressure, and even the occasional micrometeorite impact. This isn't just about creating cutting-edge technology. It's about ensuring that technology can survive and thrive in the most hostile environments imaginable. When it comes to exploring alien worlds, one of the biggest challenges is ensuring that spacesuits can survive the harsh, unpredictable conditions they'll face. Imagine stepping onto the surface of Mars, where fine, abrasive dust particles can cling to every surface and grind away at materials like microscopic sandpaper. Or picture Europa with its icy, sub-zero terrain that could crack or degrade less resilient fabrics. This is where extreme durability becomes a game-changer in advanced spacesuit design. To tackle these challenges, engineers have turned to materials like Vectran and Kevlar, lightweight yet incredibly strong fibers that can resist tears, punctures, and even extreme temperatures. Vectran, for instance, is known for its high tensile strength and resistance to abrasion, making it ideal for environments like Mars where dust storms can last for weeks. Kevlar, on the other hand, offers unmatched protection against impacts, ensuring that astronauts are shielded from micrometeoroids or sharp rocks. But durability isn't just about the materials themselves, it's also about the coatings applied to them. Specialized treatments can repel dust, preventing it from clogging joints or degrading surfaces over time. Think of it like a non-stick coating on a frying pan, but for spacesuits. These innovations ensure that suits remain functional and reliable, even after months of exposure to alien environments. What's fascinating is how these advancements aren't just about brute strength. They're about creating suits that adapt to the unique demands of each destination. From the scorching heat of Venus to the frozen plains of Europa, every planet or moon presents its own set of challenges. And that's where the next innovation comes into play: modular design. This approach allows suits to be customized for specific missions, ensuring they're not just durable, but also versatile enough to handle whatever an alien world throws their way. When it comes to designing spacesuits for the unknown, flexibility is key. That's where modular design comes in, a game-changing innovation that allows astronauts to swap out or upgrade specific components of their suits as needed. Think of it like upgrading a smartphone. Instead of replacing the entire device, you can just switch out the camera or battery. In the context of space exploration, this modular approach offers incredible versatility. If a glove gets damaged during a mission, for example, astronauts can replace just that glove rather than the entire suit. This not only saves time and resources, but also ensures that the suit remains functional and adaptable to new challenges. One standout example is NASA XEMU, or Exploration Extravehicular Mobility Unit. This next-generation suit is built with interchangeable parts, from its life support systems to its gloves and boots. If a new technology emerges or a component becomes obsolete, it can be swapped out without redesigning the entire suit. This approach drastically reduces costs over time and extends the suit's lifespan, making it a more sustainable option for long-term missions. Plus, modularity allows for customization. Each astronaut can adjust their suit to fit their specific needs or the demands of the environment they're exploring. But before these modular suits ever touch the vacuum of space, they undergo rigorous testing. Engineers simulate extreme conditions like the crushing pressure of deep space or the abrasive dust of alien terrains to ensure every component can withstand the harshest environments. These tests are critical as even the smallest flaw could jeopardize an entire mission. By thoroughly vetting each part, scientists can guarantee that these suits are not only innovative but also reliable when it matters most. This combination of adaptability, cost efficiency, and rigorous testing makes modular space suits a cornerstone of future exploration. Whether it's a mission to Mars or a journey to the icy moons of Jupiter, these suits are designed to evolve alongside humanity's ambitions. And as we push further into the cosmos, their modular nature ensures we're always ready for whatever lies ahead. Imagine stepping into a vast red desert where the horizon stretches endlessly and the terrain mimics the surface of Mars. This is NASA Mars Yard, a simulated environment where cutting-edge space suits undergo rigorous testing to ensure they can withstand the harsh realities of alien worlds. But it's not just about recreating the look of Mars or the Moon. These environments are designed to replicate the exact conditions astronauts might face, from extreme temperatures to jagged terrain and even reduced gravity effects. One of the most critical aspects of these tests is how they uncover potential flaws before the suits ever leave Earth. For example, during the Desert Research and Technology Studies program, or Desert RATS, engineers and astronauts worked side by side to evaluate how the suits performed in environments that closely resemble the Moon and Mars. They tested everything from mobility and durability to how well the suits could protect against dust, a surprisingly persistent hazard on planetary surfaces. These simulations are more than just dress rehearsals. They're vital checkpoints that ensure the suits are not only functional but also reliable in life or death situations. Another fascinating example is the use of underwater labs like NAS, a neutral buoyancy laboratory, where astronauts train in environments that simulate the low-gravity conditions of space. Here, spacesuits are tested for their ability to handle tasks like repairing equipment or collecting samples while submerged, skills that are directly transferable to missions on other planets. These underwater tests are a reminder that innovation isn't just about the suit itself, but also about how it performs in the hands of the astronauts who will wear it. What makes these simulated environments so effective is their ability to push the boundaries of what's possible, revealing challenges that might not surface in a controlled lab setting. They're a proving ground for both technology and human ingenuity, ensuring that when the time comes to explore new worlds, we're as prepared as we can possibly be. And speaking of preparation, the collaboration between space agencies and private companies has been a game changer in advancing these technologies, but we'll dive into that next. When it comes to pushing the boundaries of spacesuit technology, collaboration has become the cornerstone of progress. NASA, with its decades of experience and unparalleled expertise, has joined forces with private companies like SpaceX, Axiom Space, and Collins Aerospace to create next-generation suits designed for the most demanding environments. These partnerships bring together the best of both worlds: NASA, a deep knowledge of space exploration, and the private sector's agility, innovation, and resources. Take SpaceX, for example. Their Extravehicular Activity, or EVA, suit is being developed specifically for lunar missions, aiming to provide astronauts with unparalleled mobility and protection. Unlike the bulky suits of the past, these new designs prioritize flexibility and durability, allowing explorers to navigate the Moon's rugged terrain with ease. Axiom Space is another key player, working on suits that not only meet the technical demands of space, but also incorporate advanced materials for enhanced comfort and safety. Meanwhile, Collins Aerospace is focusing on modular designs, making it easier to adapt suits for different missions, whether it's a spacewalk near the International Space Station or a long-term stay on Mars. These collaborations aren't just about sharing resources, they're about accelerating innovation. Private companies can move quickly, testing new ideas and iterating on designs at a pace that traditional agencies might struggle to match. By combining NASA's rigorous standards with the private sector's cutting-edge technology, we're seeing spacesuits evolve faster than ever before, suits that aren't just functional but revolutionary. But the story doesn't end there. This spirit of collaboration extends beyond borders, with international partnerships playing a crucial role in advancing spacesuit technology. As space agencies around the world share knowledge and resources, the dream of exploring alien environments becomes a collective effort, bringing humanity one step closer to the stars. One of the most fascinating aspects of modern spacesuit innovation is how it's being driven by international collaboration. It's no longer just one nation racing to the stars today. Space agencies like NASA, the European Space Agency, and Japan's JAXA are pooling their expertise, resources, and funding to push the boundaries of what's possible. This global effort isn't just about sharing the workload. It's about combining the best ideas from around the world to create technology that's greater than the sum of its parts. Take the Lunar Gateway project, for example. This international space station set to orbit the Moon is a testament to what we can achieve when nations work together. The advanced spacesuits being developed for this mission are a direct result of this collaboration, incorporating cutting-edge materials and life support systems designed by experts from multiple countries. But it's not just about the technology itself. It's about the shared vision of exploring and understanding the universe. By working together, these agencies are accelerating progress in ways that would be impossible for any single organization. Imagine the breakthroughs that come from combining JAXA precision engineering with ESA's expertise in life support systems, or NASA's decades of spaceflight experience. Each partner brings something unique to the table, and the result is a new generation of spacesuits that are safer, more durable, and more adaptable than ever before. Of course, with such ambitious projects come ethical questions. As we venture further into space, how do we ensure that this collaboration remains fair and equitable? Who gets to benefit from the discoveries made? And how do we balance the pursuit of knowledge with the responsibility to protect the environments we explore? These are complex issues, but they're essential to consider as we take these next giant leaps. Because at the heart of every innovation, every mission, and every international partnership, there's a shared goal: to explore the unknown, not just for one nation, but for all of humanity. As we marvel at the technological feats of advanced spacesuit design, there's a pressing question we can't afford to ignore. What are the ethical implications of creating gear for environments we've never fully understood? Crafting suits for alien worlds isn't just about functionality, it's about responsibility. For instance, how do we balance the need to protect astronauts with the potential risks of contaminating extraterrestrial ecosystems? Imagine introducing Earth-based microbes to a pristine Martian environment. While our suits are designed to keep us safe, could they inadvertently harm life forms or ecosystems that might exist beyond our planet? This dilemma raises another critical question: should human safety always come first? Or do we have an obligation to preserve the integrity of alien worlds, even if it means limiting our exploration? It's a debate that echoes the environmental challenges we face here on Earth, but with even higher stakes. After all, these are environments we've only just begun to study, and the consequences of our actions could be irreversible. Another layer to this ethical puzzle is the issue of access. Space exploration has historically been dominated by a handful of nations and organizations with vast resources. But as we push further into the cosmos, who gets to benefit from these advancements? Should space technology remain the domain of the privileged few, or do we have a moral imperative to ensure equitable access? This isn't just about fairness, it's about fostering a global approach to space exploration that reflects our shared humanity. These ethical considerations aren't just theoretical, they're shaping the future of space exploration. And as we grapple with these questions, another challenge emerges. How do we make these cutting-edge technologies not only ethical but also accessible? That's where the conversation shifts to cost and practicality, a topic we'll explore next. One of the most significant challenges in pushing the boundaries of advanced space suit technology isn't just engineering, it's economics. Developing these suits involves cutting-edge materials, intricate life support systems, and rigorous testing, all of which come with a hefty price tag. To put it into perspective, a single advanced spacesuit designed for alien environments can cost tens of millions of dollars. That's a staggering figure, especially when you consider the need for multiple suits to support crewed missions or long-term exploration. But here's the question: how do we make this groundbreaking technology more accessible without compromising its capabilities? One promising strategy lies in reusability. Unlike traditional spacesuits, which are often tailored for specific missions, the next generation could be designed to adapt to multiple environments and missions. Think of it like a modular system. Swap out components like gloves, boots, or life support packs depending on the destination, whether it's the dusty plains of Mars or the icy moons of Jupiter. This approach not only reduces waste but also spreads the cost across multiple missions, making each suit a more cost-effective investment. Another innovative idea gaining traction is the concept of rental or shared suits. Just as companies like SpaceX have revolutionized space travel by reusing rockets, space agencies could adopt a similar model for suits. Instead of each mission requiring a brand new set, suits could be rented for specific missions, refurbished, and then reused for future expeditions. This could significantly lower costs while still ensuring astronauts have the best possible equipment for their needs. Of course, government subsidies and partnerships with private companies will play a crucial role in making these suits more accessible. Space exploration has always been a collaborative effort, and pooling resources could help offset the astronomical costs. Programs like NASA Artemis initiative or partnerships with private aerospace firms could pave the way for more affordable, cutting-edge spacesuit technology. And let's not forget the potential for international collaboration. By sharing the financial burden, nations can collectively push the boundaries of what's possible. As we look to the future, the evolution of spacesuit technology isn't just about solving today's challenges, it's about building a foundation for what comes next. Imagine suits that not only protect astronauts but also enhance their abilities with integrated AI, augmented reality displays, or even self-healing materials. These advancements could redefine how we explore alien worlds, making the dream of interplanetary travel more attainable than ever. The question isn't if we'll get there, it's how we'll make it happen. And with the right strategies, the stars might not be as far out of reach as they seem. As we look ahead, the future of space suit technology promises to be nothing short of revolutionary. One of the most exciting advancements on the horizon is the integration of built-in propulsion systems. Imagine a suit equipped with small, maneuverable thrusters that allow astronauts to navigate microgravity environments with unparalleled precision. This could transform how we conduct repairs on spacecraft, explore asteroids, or even build structures in orbit, giving astronauts the freedom to move effortlessly through the void of space. Another groundbreaking development lies in the use of nanotechnology enhanced materials. These futuristic suits could feature fabrics that repair themselves, adjust their insulation based on external temperatures, or even shield against harmful cosmic radiation. Picture a suit that senses damage and instantly initiates microscopic repairs, ensuring the astronaut's safety without any manual intervention. This level of innovation would not only enhance durability, but also reduce the need for bulky, redundant systems, making space exploration more efficient and adaptable. But perhaps the most fascinating possibility is the emergence of bioengineered suits. These could be designed to adapt physically to the wearer's body, optimizing fit and function in real time. By incorporating materials that respond to muscle movements or changes in body temperature, these suits could provide unprecedented comfort and support, reducing fatigue during long missions. Some concepts even suggest suits that integrate with the astronaut's biology, potentially monitoring vital signs or delivering medical assistance autonomously. These advancements aren't just about creating better tools for astronauts, they represent a shift in how humanity interacts with the cosmos. Suits with built-in propulsion could open up new frontiers for exploration, allowing us to reach distant moons or asteroids with ease. Nanotechnology enhanced materials might pave the way for longer, safer missions, while bioengineered designs could blur the line between human and machine, enhancing our ability to thrive in hostile environments. The implications of these innovations extend far beyond space exploration. They could inspire breakthroughs in fields like medicine, robotics, and materials science, bringing space-age technology into our everyday lives. By pushing the boundaries of what's possible, these next-generation space suits remind us that the future of humanity is not confined to Earth, it's written in the stars. Advanced spacesuits are far more than just protective gear. They're a testament to the boundless creativity and determination of humanity. These suits represent our ability to adapt, innovate, and push the boundaries of what's possible, even in the harshest environments imaginable. They're not just tools for survival, they're symbols of our relentless pursuit of discovery and our refusal to be confined to Earth. Think about what it takes to design something that can withstand the crushing pressures of alien atmospheres, the searing heat of distant suns, or the freezing void of space. It's not just about engineering, it's about envisioning a future where humans can thrive beyond our home planet. These suits are the foundation for long-term colonization of other worlds, enabling us to build sustainable habitats, conduct research, and maybe even establish new civilizations. But they also play a crucial role in something even more profound, the search for extraterrestrial life. With advanced suits, we can explore environments previously thought uninhabitable, like the icy oceans of Europa or the methane lakes of Titan. They give us the ability to search for signs of life in places where life as we know it shouldn't exist, and that's where the most exciting discoveries might be hiding. So, as we've explored throughout this video, these suits are more than just high-tech clothing. They're a bridge to humanity's future, a way to extend our reach into the cosmos and uncover the mysteries of the universe. From their cutting-edge materials to their life-sustaining systems, every detail reflects our collective ambition to explore, survive, and thrive in the stars. This isn't just about technology, it's about what it means to be human. It's about our curiosity, our resilience, and our unshakable drive to explore the unknown. Advanced spacesuits are a reminder that no matter how vast the universe is, we have the ingenuity and determination to make it our own. And with that, we've covered the incredible evolution of spacesuits, their groundbreaking features, and how they're shaping the future of space exploration. Whether you're a space enthusiast or just someone fascinated by human innovation, these suits are a powerful symbol of what we can achieve when we dream big and push the limits of possibility. The advancements in advanced spacesuits represent a giant leap forward in our ability to explore the cosmos. From self-healing materials that repair themselves in the harshest conditions to AI-powered systems that monitor vitals and adjust to environmental changes in real time, these innovations are redefining what's possible. These suits aren't just protective gear, they're lifelines, enabling humans to survive and thrive in alien environments that were once thought utterly inhospitable. Think about it, a suit that can detect a tear and seal it instantly, or one that uses artificial intelligence to anticipate your needs before you even realize them. These aren't just tools, they're partners in exploration designed to push the boundaries of human capability. But with every breakthrough comes new challenges. The journey to perfecting these suits is far from over. We still face hurdles like ensuring long-term durability in extreme conditions, improving energy efficiency for extended missions, and making these technologies accessible and cost-effective. Yet, these challenges are also opportunities for collaboration, innovation, and discovery. By bringing together scientists, engineers, and visionaries from across the globe, we can turn these obstacles into stepping stones for even greater achievements. As we look to the future, one thing is clear: the success of space exploration depends on our collective curiosity and determination. Every step forward in developing these suits brings us closer to answering some of humanity's most profound questions. Imagine standing on the surface of Mars, Europa, or even an exoplanet protected by a suit that's a marvel of human ingenuity. What will we learn? What will we discover? And how will these experiences reshape our understanding of the universe and ourselves? So let's keep pushing the boundaries. Let's support the researchers, engineers, and dreamers who are making these incredible advancements possible. And most importantly, let's stay curious, because the future of space exploration isn't just about technology, it's about us. It's about what we can achieve when we dare to dream big and work together. So, here's a question to leave you with. What will humanity achieve when we finally step onto another world, clad in these incredible suits? The answer lies in the choices we make today. Did you know that the iconic Apollo spacesuits worn by astronauts walking on the moon were actually hand-sewn by skilled seamstresses? It's true, these highly specialized suits, designed to withstand the vacuum of space, were crafted with precision and care, much like a tailor creating a custom suit for a high-profile client. These seamstresses worked with materials like beta cloth, a fire-resistant fiberglass fabric, stitching together layers that would protect astronauts from micrometeoroids, extreme temperatures, and radiation. It's a fascinating reminder that even the most advanced technology can rely on timeless craftsmanship. And speaking of firsts, the very first spacesuit wasn't even designed for space travel. It was created for high-altitude balloon flights in the 1930s. Pioneering aviators like Wiley Post, who wanted to break altitude records, needed protection from the thin, freezing air above 30,000 feet. His suit, pressurized and made of rubberized fabric, laid the groundwork for the suits we see today. It's incredible to think how far we've come, from balloon flights to exploring alien worlds. Here's another fun fact: modern spacesuits aren't just built for survival. They're designed with mobility in mind. NASA next-generation suits, like the ones planned for Artemis missions, will allow astronauts to bend, twist, and even kneel with ease, something that was nearly impossible in earlier designs. This flexibility is crucial for tasks like collecting samples on the Moon or Mars, where every movement counts. And let's not forget about color. Why are most space suits white? It's not just for aesthetics. White reflects sunlight, helping to regulate the suit's temperature in the harsh environment of space. But for lunar missions, you'll notice astronauts often wear suits with gold-plated visors. That's because gold is excellent at blocking harmful ultraviolet rays, protecting their eyes while they explore the Moon's surface. These little details make space suits so much more than just protective gear. They're marvels of engineering, history, and human ingenuity. And if you think this is fascinating, just wait until we dive into the next topic: how futuristic habitats are being designed to support life on Mars and beyond. Stay tuned, you won't want to miss it. If you've enjoyed this deep dive into the world of advanced spacesuits designed for alien environments, don't forget to hit that like button and subscribe to the channel for more cutting-edge content on futuristic technology and space exploration. Your support helps us keep uncovering the innovations that are shaping the future of humanity beyond Earth. We'd love to hear your thoughts. What excites you most about the future of space travel? Are you fascinated by the idea of exploring Mars, or maybe you're dreaming of missions to distant moons like Europa or Titan? Drop a comment below and let us know what you're most looking forward to. And if you found this video insightful, consider sharing it with friends or fellow space enthusiasts. Together, we can spark more conversations about the incredible possibilities that lie ahead. Stay tuned for our next video, where we'll dive into another groundbreaking topic in the world of futuristic technology. Until then, keep looking to the stars, because the future is closer than you think.